All right, so let's see what we got for today. So there's two objectives, and again, this is one lesson, but I'm going to break it into two smaller lessons for this week. And again, this week is going to be the last week that we're going to have lessons, because next week is the final week, and I'm going to set that time aside for final exams, which is, you should already have it by now. It's just labeled week 18 packet, and I'll explain the rules for that probably after this. It's pretty easy, but I don't know, I'm guessing I'm going to get some questions on it. So what we're going to focus on first is use the discriminant to determine the number and types of solutions. We'll go ahead and save this one for the next lesson, and this one ties into this one. And using the discriminant, so if you remember from the last lesson, when we were working with quadratic formula, as we went through some of them, I was pointing out, some of these would be pretty good on other methods. So like, even though we used quadratic on all of them, there would be faster ways, there would probably be easier ways if you were using another method. So I'm going to kind of show you a trick that you can use to quickly find out what kind of zeros you're going to get. And this will also help you to decide which method is the best method. So we covered a lot of methods the last time around. So some of the methods that we covered were things like factoring, completing the square, solving by square roots, and a couple of other ones. Quadratic formula, I think, was the most recent one that we covered. So let's go ahead and look at some of these. And now again, this is actually going to be for next time. So I'm going to go ahead and skip down to the part that's important for us. So what is important for us is that we need to know the discriminant. All right, so discriminant sounds kind of, I don't know, especially nowadays, it probably sounds like it's something bad, but discriminate just pretty much means to kind of make sense of it, to categorize it, or something like that. So it basically is a way of telling us this part here. So if we look at the quadratic formula, we can see that there's this spot underneath the radical. And during the last lesson, I was also pointing out, this is going to be something that's going to happen. So you can oftentimes tell what kind of solutions you're going to get just by looking at this area underneath the radical. So in this case, we're going to take that part underneath the radical, the b squared minus 4ac, and we're going to do that part first. So by working with it first, this will tell us what we're looking at. So again, just this part here. We don't have to worry about all the stuff on the outside, because right now we're just trying to find out what are we looking at. So again, it's kind of like if you were to call an auto mechanic. So some mechanics don't really work with some don't work with some things, like you can't go to, what's that place, Valvoline or Quick Lube, and expect to, they'll probably do tire changes on the oil, windshield wiper fluid and all that stuff, but they're not going to work on your transmission. They're not going to work on struts. Some stores only do body work. So in a way, this is kind of like knowing what you're dealing with so you can bring the right kind of tool for the job. And again, that's our discriminant. So if we look at the value of the discriminant, there are a couple of outcomes that we can get. So the first one is discriminant that is greater than 0. So I know sometimes you look at this and you're like, what does that mean? Can't they, well, it just means it's positive. So if the discriminant is a positive number and a perfect square, that means you will have two roots that are real and rational. So you have two real roots and rational. If you remember that there was a, we had a diagram that we went like that. So you had natural numbers. You had, after natural numbers was whole numbers. Then you had integers, which were z. Then you had rational. Now I forget what those are. I think they were q. We call them q, but those are rational numbers, and those are fractions. So when they say real and rational, it means it can be natural, it can be a whole number, it can be an integer, and it also can be a fraction. So fraction is the worst type of, well, I don't want to say worst because it makes it sound like it's bad. It's not bad. It's just, You know, I know people don't like fractions, but that's the worst that you have to deal with. So that's what happens if your discriminant is positive and a perfect square. Oh, perfect square. Remember, those are numbers like 1, 4, 9, 16, 25, 36, 49, 64. Any of those numbers that you can get by multiplying a number by itself, those are perfect squares. All right, so let's go ahead and move on to the next one. So the discriminant is still positive, but it is not a perfect square. So that is any number that is not a perfect square. Like for instance, if I just pick two numbers that I just got done saying, so I think I said 9 and 16, those are perfect square numbers, but all the numbers in between, so like 10, 11, 12, 13, 14, 15, if it's anything that's in between square numbers, then it's not a perfect square. But what kind of solutions will we get? And remember, roots are another way to say solutions. So with these top two here, if we imagine a parabola, because we're still dealing with quadratics, two solutions kind of looks something like this. So that means that there are two contacts with the x-axis, right? There's an x and a y. And in this case here, if it's not a perfect square, you still have two roots. They are still real, but they are irrational. So that just means that you're going to get like a crossing, you know, you're going to have a solution that would be something like square root of 15. Like just as an example, if I type in square root of 15, where did my calculator go? So let me just go ahead and type that in. So 15, so 1, 5, and then square root. And we get something like that. So we get that whole big number with a lot of decimals. So in this case, it's like 3.873, so on, so on, so on. That's all it means. You're just going to have something like this, or if you're solving it, you're probably going to have something that looks a little bit different. It'll still have a radical in the answer, but you will still have 2 points of contact with the x-axis for both of these. All right, now to the next one. What if the discriminant is equal to 0? What if it comes out to be exactly 0? So we had a couple of these on that one when we were going over quadratic formula. When your discriminant is 0, that means you're only going to have one solution. Okay, so what does that look like if we graph it? So if I were to graph it, it would probably look something like this, where you only have 1 point of contact with your parabola and the x-axis. Now, when you're solving these, you know, mathematically or algebraically, you would get two of the same answers. Now, we still say there's only one, even though you solved it twice. You solved two different equations. Well, they're not really different equations. This is the same equation, but you came to the same number. Well, you don't say the same number twice, right? So if somebody asks you how old you are, you don't say, I don't know, like, well, for me, the most common age I deal with is 17. So I'm gonna say, you know, if I ask a student, hey, how old are you? And they say 17, 17, they don't need to say it twice. It's the same number. So that's why we say there's only one root, even though when we solve it, sometimes it looks like there's two of them, but it's the same number, so we don't need to say it. All right, and then you're also gonna have real or rational number solutions. So if you know, it's gonna be probably a fraction, but it's not gonna be crossing or touching at a point where it would be irrational or with a square root. All right, so that brings us to the last one, and that is imaginary. And now all of these numbers here, if you remember when we were looking at number classifications, we had a larger circle, and that was real numbers, which is R. And then we also have irrational numbers, which I think we mark with capital I. And it changes every year, because I remember when I was a kid, these letters marking were different. So anyway, so these are all real numbers here. Now we're going to be dealing with something that is not a real number. So if your discriminant is less than 0, well, that means you have a negative square root. And you are still going to have two roots. However, they are going to be imaginary. And one of the other things we covered, and this is like, I don't know, a lesson from like 3 weeks ago, imaginary numbers are actually on the outside of real numbers. So real numbers, well, kind of are imaginary numbers as well. Oh, sorry. not capital I, we need the cursive I, that special cursive I that looks like that. And then you also have complex numbers, but that's not really something we can get from this. And if we were to graph that, it would look something like this, where you have no contact with the x-axis. So does not cross, you know, it could cross, it thinks about crossing, which is probably why we call it imaginary, because if we were to change a few numbers, we could get it to cross, but then it wouldn't be the same equation anymore. But these parabolas, you know, they kind of move up, down, side to side. They do a lot of other things too. So anyway, those are the 4 types of discriminants that you can have from working on some of these. Now, I'm going to go ahead and we're going to work with some of these problems that we will look for the discriminant. So there are actually 3 questions in this, and this is why it's important to read the directions. So there are 3 questions. The first one is find the value of the discriminant. So we got to find out what the discriminant is, then determine the number. So that's the second one. How many solutions are there and what types of solutions? So if we have that chart on the last slide, this one shouldn't be, should be pretty easy as long as you have them all down. All right, so now we have some quadratics, right? So this one is in standard form. And again, that's important. First thing you should check is if it is in standard form, which in this case it is, because x squared, x to the 1, and x to the 0. So they must be in descending powers, and it must also be set equal to 0. So those are the 2 things that you have to check before you start working on it. And I'm going to mark my A, B, and C, and I am also going to get my discriminant. So that's, again, negative, oops, sorry, I almost got the whole thing. I don't need the whole quadratic formula. I just need this part here. So again, just the discriminant, which is actually part of the quadratic formula. So it actually sometimes will come in handy also later on the same problems if you ever need to use quadratic formula. All right, so now let's go ahead and plug this in. So b squared, that's going to be 12 squared minus 4 times our a value, so a, and then c. And that's all we need to do. Make sure we use each number once. And then we're going to evaluate this. So evaluate just means, you know, do the operations. So if you see a square like that, let's square 12. Now, I have 3 things going on here, and I like to do these 3 things all at one time because I already know that multiplication is commutative, which means no matter which order we multiply them, like if I have 4 times 2, then 13, it would be the same thing as if I were to go 13 times 2, then 4. Or 4 times 13, then times 2. Doesn't matter which one I do, they're all going to the same place, okay? Just like when I go to the movie theater and I buy a whole bunch of snacks, all right? Doesn't matter which one I'm gonna eat first because they're all going to the same place. I miss movie theaters in some ways. Anyway, first thing I'm gonna do is I'm gonna look at the sign. So I have 2 negatives, right? Negative here, negative there. And that means that no matter which order I multiply them in, I'm always gonna have 2 negatives at some point multiply to each other, which means I'm gonna have a negative. So again, I have 2 of them, so that's an even number of negatives, so that'll be positive. Okay, now I know what the sign is. I can go ahead and just focus on the numbers. Now let's see, I have 4 times 2, which will give me 8. 8 times 13, I don't know what 8 times 13 is, I'll be honest with you. I mean, we all memorize the times table, but usually it only goes up to about 12. And I could easily look behind me and look at the multiplication chart, but you know what? I can pick different numbers. So I'm going to go with 2 times 13, which is going to be 26. Now, if I told you what is 4 times 25, you'd easily know what it is. Be 100. But now let's just add one number on from 12 to 13. So that's one number. 1 times 4 is 4. So that means that this is going to be 104. So that makes, that's just a quick, easy way that you can do it. You don't have to do it that way, all right? Because I know a lot of people are gonna be like, well, you know, why don't I just use a calculator? Okay, fair enough. So I'm gonna go ahead and add these 2 together. So 4 and 4 is gonna be 8. 0 plus 4 is 4. And then 1 and 1 is going to be 248. So once I put them all together. So that's the first part. We found the value of the discriminant is going to be 248. All right, so since we're answering multiple questions, I'm going to go ahead and I'm going to show that this is a different answer by putting a semicolon there. Okay, I made sure I knew which one it was called today. Then determine the number and type of solution. So here we have a discriminant that is positive. So we know it has two real roots. The question is, are they rational or irrational roots? So what we got to do is test it out. Now, there's a couple of ways you could do this. You could memorize the times table. So remember maybe like 5 lessons ago, well, maybe like 5 weeks ago, but it was a long time ago. I had you memorize the perfect square numbers. So like 64, 89, 100, and we went all the way up to 400. So if you have that list, you could just check to see if 248 is on that list, which in this case, it's not, because I know that the square root of 16, I'm sorry, not the square root of 16, the square of 16 is 256. And if I look at the, because my times chart behind me says 15 times 15 is 225. So this number is over 225. I think that's what I said. Yeah, 225. And it's less than 256. So that means that this is not a square number. And you can just go ahead and look back here at the chart. So it's not a square, which means that there's going to be 2 real irrational roots. So I'm going to go ahead and just put that 2 real irrational. And we're done with that one. So again, it seems like it took a while, but that was just mostly me explaining why things are what they are. All right, let's go ahead and move on to the next one. So let's go ahead and find the value of the discriminant. So I'm going to get b squared. So this is going to be 16 squared, which I just got done explaining that I know what it is. Now, don't forget, when you have these substitutions, you also have to substitute in the sign, which in this case, normally if I had 1, I would just skip it because I already know that 1 times 1 is going to be the same thing or isn't going to have a change. But since I have a negative here, I have to count that as -1. All right, so now I have all of the things in there. I should use each number once. Looks fine. So 16 squared. Now I know this one. I know this one because I remember, I don't remember what age I was, but I was maybe 10 years old when I first saw, what I saw was the first color computer. Before that, computers either had 1 color or up to 4 colors. I think my grandparents had like up to 1 that had 16 colors. But either way, it was more like shades of gray. It wasn't really like actual colors. But I remember being blown away by seeing a computer with 256 colors, and I was like, wow, the future is here. Now it's much higher than that. Anyway.
Now we have more colors on our computers.
Yeah, I know, seriously. I think it's like now they have like a slider with a bunch of shades. But back then they had 16 colors and 16 shades of each of those colors. So yeah, it was mind blowing at the time, but now it's like whatever. It's like if you saw that computer, you'd be like, man, what the heck was up with people back then?
They're probably like, damn, it's not even mind blowing anymore.
Yeah, now I think it really is tough to get people to be awed by things. Anyway, I don't know. Now when something new comes along, we're just like, whatever. Anyway, so I have 3 numbers that are negative. So this means that, negative times negative is positive. Positive times negative is going to be negative. And it doesn't matter which order I go in. So there's 3, which is odd. So that means it's going to be negative. Odd number of negatives means it's going to be negative. And I'm going to go ahead and ignore 1 because I already know I've already taken its negative into consideration. So I'm going to go 4 times 64. So 4 times 64, that's going to be 128 times 2, which is 256. 4 times 4 is 16. Hold on to the 1 mentally. 6 times 4 is 24, plus 1, that's 25. So yeah, it is 256. Again, just a really short thing. You don't have to do that. Like I like to do that to keep my brain sharp from time to time. All right, so we get 0. All right, now this one's a special case because if we have a discriminant of 0, that means that we are going to have one root that is real and rational. All right, so one real and rational root. Oopsie. All right, and that's done with that one. Let's go ahead and move on to the next one. So same thing, we got to make sure that this is in the right form, right? This is not standard form because X should be the second part. So I'm gonna have to do a little bit of changing up before we can use this. So again, it must be set to 0 and it must be in descending powers. So this means before I do anything, I'm gonna have to minus 10x from both sides. And since I don't have a term of x on this side, the left side, I'm gonna go ahead and just put it right in between those two numbers. And that should be enough to get them to be, that should be enough to put them in the right spot. All right, so from here, now we should know what we have. So we have b squared. Well, actually, you know what? I'm going to rewrite it again anyway, just so that way it's a little bit less confusing. So negative 4x squared minus 10x plus 84. So there we go. And then put it equal to 0 because it has to be equal to 0. There you go. Now we can put it into our discriminant. So negative 100 squared minus 4a, which a is negative 4, and c is 84. All right, now let's go ahead and multiply this out. Well, actually, we're going to square negative 10, which is negative 10 times negative 10. Negative times negative is positive. 10 times 10 is 100. Look at our signs, because again, we have 3 of them, 3 terms that we're multiplying, but 2 of them are negative. So that's going to actually turn this into a positive. And here I would have 16 times 84. And that doesn't really help us out because I don't know what that would be. And if it doesn't matter which 4 I use, it's going to be 16 times 84 somehow. And 84 times 4, I don't know what that is. So maybe this is a good one to use a calculator on. So 4, well, I can just go 16 times 84. And that would be 1,344. And I'm going to put these two together. So I have 1,444. And that's the number of our discriminant, the value of our discriminant. And this is a pretty big number, but the question is, will this be a rational number or an irrational number? So I'm going to go ahead and bring up the calculator and let's go ahead and do that one. Now, if you're watching this, you're probably already using the internet. And if you don't have a calculator, just go to Desmos, what we've been using all year, and use it. Oops, sorry, I accidentally pressed it twice. So just need to press it once. So there we go. And you get a whole number. If you take the square root of a number and it becomes a whole number, so no decimals or anything like that, then it means that it is a perfect square number. So in this case here, it's going to be our first option on the list. That was D is greater than 0 and is a perfect square. So we're going to have 2 real rational roots. So 2 real and rational. That O looks a little bit off. And all of this is our answer. So we're going to box all of that up. All right, last one for this one anyway. Now, sometimes this happens where you're missing a term, right? We're also missing an x variable as well. If you're missing one, then it's going to be 0. Now, this one's a bit confusing because if you don't see something, but you do see the variable, so this one's lacking a coefficient, that's the number in front, that's going to be a 1. If it's completely missing, as in there's nothing at all, then it's going to be 0. So as we fill in b squared, well, there is no b, so we're just going to have to put 0 there. All right, so in this case here, 0 squared is going to be 0. And then is 4 times 3 good? Like, can I go 12 times 24? Actually, I think that would work out. Yeah, that would work out. 12 times 24. Okay, but you're going to say, but hold on, that's a big number. I wouldn't know a times table. Well, you could go 12 times 12, which would be 144, and double that. And I didn't really even think about that. But one other thing we could do too is pick 2 numbers, and let's see if we can get 2 numbers to be easily multiplied to something we already know. Like in this case, if I ask you, what is 4 times 25? 4 times 25 is 100. Now we could do that, so we'd get 300. But remember, we took 1, we added 1 to this 24. Now we have to take it back. How do we take it back? Well, how many 24s were there? There were 12 of them, which we got from here. So 300 minus 12 is that, and that's going to be 288. All right, and again, it's another one of those weird tricks. All right, I know some of you guys are just going to be like, well, I have a calculator. Fine. But you never know when you're going to be stranded on a desert island with nothing, with no calculator or anything like that, and you need to get out using math. Hey. Anyway, so first off, we can already tell what this is going to be. We are going to have a negative number. And if we look at the chart, negative number means we're going to have 2 imaginary roots. 2 and imaginary. And there we go. So that takes care of all that. Now, this is actually going to tie into something else. And if you remember on the objectives, there was a second objective, and that was to determine the best method for solving a given quadratic. So how do you choose the best method? Okay, so we learned what the discriminant was, but how do we use it? So you use the discriminant by finding out what you're dealing with. Like I said, it's kind of like, I guess the best way I could tell this story is, so like, with my sister, if she says I have a house problem, I'm like, well, what's the problem? The better description I can get, the more prepared I can get, because I can bring the right tools to it. If I'm dealing with a water heater, you're going to need wrenches, pipes, and pipe cutters and stuff like that, maybe. You might have to deal with some electrical work. It's really different no matter what you're working on. So it's always going to be a little bit different. So sometimes you will need to bring special things. But again, that's kind of like knowing what you're dealing with so you can be more prepared for it. So if you know what your roots are, you can pick one of the methods. So graphing can be used sometimes. Now graphing is, well, I'm going to go really short through this, but graphing is the one that you would look for the axis of symmetry. That's the negative b over 2a. And then you would plug that back in and make a table where that number is the middle number, and then pick some numbers going up, some numbers going down, and seeing which way it goes. Now, sometimes that's kind of tough because, if you have numbers that are going away from the axis, that's not going to really help. So it has to be a real number, and it has to be an integer. So your roots cannot be negative numbers. They cannot be the roots of numbers. Like, for instance, they cannot be the square root of 5. Nope, that's not going to work. So again, roots, if you know they're integers, then you can use graphing. So that's not a very helpful method. But what about factoring? Okay, let's try factoring. When can you use it? Well, you can use it sometimes, and it works best when your roots are rational. So if your roots could be fractions and you're pretty sure they are fractions, factoring is just fine. You can use roots that are fractions by using the AC method, which if I remember correctly, there's going to be an example of that. later. But if your roots are rational, you can use factoring. Or sometimes you can just look at something and say, oh man, I can factor that. And I don't know how common that is, all right? But for me, I can just look at something and say, oh, I can factor that. But I don't know. If you don't know, well, there's other methods you could try. So what about the square roots? Square root method can be used sometimes, and it works best when there is no B term, when there's no middle number. Sometimes I call that the X terms when I'm talking about the descending powers. In fact, actually on the last slide, there was an example, and I'm gonna go through it really quick just to show you how fast it can go. So in this case here, for number 4, we were missing a B value. So if you're missing a B value, all you have to do is sort of solve it like you're just gonna work with a normal algebra problem, right? We wanna get that X by itself. So I'm gonna move the 24 over to this side by subtracting 24 to both sides. Divide both sides by 3, and that gets rid of the 3, so I'm a little bit closer on getting that X by itself. And then from here, I'm just gonna take the square root of both sides, and that will undo the power of 2, or the square, and then I'm gonna have square root of -8. But I can also break down, oops, I forgot the plus and the minus almost, which is another thing you gotta worry about. Break down -8, and I have X is equal to plus and minus, oops. You know, I don't really need the squiggly parentheses, but I know it's gonna be, I can take the square root of 4, that's gonna be 2, -1 is I, so I'm gonna put I here, and then I can't take this 2 out because it's not a square number, and we're done. Now I probably could have skipped these 2 middle steps, and from here I could have just gone straight to here. But that just, again, really quick way of just showing you how easy it is sometimes. And that's using the square root method. All right, and again, in this case here, we looked at it and we were able to get imaginary roots, and it works with pretty much anything as long as there's no B value. You can find an imaginary number, you can find an irrational number, which in that case, I think number 4 was both of those. Anyway, last one for now is gonna be completing the square, which can always be used, right? Always, you can always use it. And that's the one where you have to do the your B value and take it, oopsie, half it, square it. So that's the one where you have to move your C value over to the other side, and then look at your B, take it, half it, square it. Whatever you get, add that to both sides of your equation, and then continue solving. But it works best when you have no X squared coefficient. Now that's not a really like hard and fast rule, because you can, even with a X squared coefficient, you can still use it. And it works also best when you have an even B value. So if your middle number on the standard form is even, that's when it works best. So, but again, it sometimes, I mean, sorry, not sometimes, it sometimes always works. But no, in this case, it always works. You can use it on pretty much anything. But these are just some things that it works better at. And then you have your quadratic formula. So these were the last ones before quadratic formula. So quadratic formula, I described it as like it's the big hammer, okay? It's the big tractor that can do any job. All right, you don't want to use it all the time because it's big, you know, like if you imagine a construction site, yeah, you can use the big tractor on everything, including digging small ditches or moving a small amount of stuff. But the problem with the big tractor is that it's very slow and it doesn't really, well, it works on everything, but it takes a long time and it takes a little bit of extra work moving that big tractor. So even though it can always be used and you can use it anytime, any kind of solutions, well, yeah, sometimes the other methods are just faster, better, you know, like that last one we saw, you know, if you ask me that, I could probably have solved it in like 3 or 4 seconds or something like that. I probably could have solved it before I was done writing it. Anyway, but that's quadratic formula, can be used all the time. But we're gonna try to look at some of these problems and see which one would be the best one. So what is the best method? So For this one here, we have 4 equations. So we have equation A, B, C, D. So those are our 4 equations. Now it says to find the discriminant of each equation and give the number and types of roots. So it's the same thing that we did on the previous exercise. But there's going to be a little bit of extra work on this one, because not only do we have to know it, but we're going to have to be able to use it later. So let's go ahead and get our discriminant. So that is b squared minus 4ac, just to remind you. Check to see if it's in the right order. Yep, and it's set to 0, so this one's ready to go. I'm going to go through these a little bit faster, just so that way you can kind of get a feel for how fast these are. And you know, because sometimes a lot of times people don't want to do these. In fact, actually with this assignment right here, I always get students that skip this part here. This part is part of the assignment. It is required for all of these to get full points. All right, so make sure you follow the directions, because it says find the discriminant, give the number and types of roots. So I do get people that will skip these. All right, so minus, because I only have one minus, 1 is an odd number. 4 times 21, that's going to be 84. So our first one is going to be -3. Since it is a negative, that means there's going to be 2 imaginary roots. -3 and 2 imaginary roots. All right. So that's the first one. And sometimes I'll get students that are like, why do we need to do this step? Well, sometimes it's useful because you'll know which one to work on. And again, it's like getting a description. It's like if someone told you, hey, can you come over to help me with something? You know, it's like, that's not a really good answer. You know, do I need to bring a shovel? Do I need to bring, I don't know, mechanic tools? Do I need to bring pipe tools? You know, the better description, the better I can do to help. So sometimes you can actually save yourself a little bit of work by looking this over. All right, so in this case here, we are missing a b value, and it is in order already, -4 times a times c. All right, so 0 squared is going to be 0, and this is going to be plus 8 times 144, 8 times 144. Get my calculator out on this one here, 8. I don't know what 8 times 144 is, and I probably could do 4 times 288, but that doesn't help me either. So I'm gonna go ahead and just go with 8 times 144 on my calculator, and I get 1,152. Which this is gonna be pretty easy, because I know that adding 0 to anything is not gonna change it. So the next question is, will this be a perfect square number? So I'm gonna go ahead and just push the perfect square number button on my calculator, and it is not. So that is not it's not a square number, but it is positive. So there are 2 real roots. However, they are going to be irrational. I'm kind of writing them stacked on top of each other just so I can fit them in, because I don't want to, if I write it too wide, you know, I might put my answer into one of the other areas that the answer goes in. But anyway, we got it. We got the discriminant and the number and types of roots. Equation C. All right, so equation C. Go ahead and just start putting it there. Make sure it's in order and all that stuff. So -22 squared, and in this case, I'm going to put a parenthesis on it. Oops. -4 times A times C. All right, so what is 22 squared? Now, if you ask me what is 20 times 20, I would know that would be 400. So 400, and then in this case here, I have, so that's 20 times 20, but what about the 2? So that would be like 4 times 22, which would be 84. So that would be 484. And again, don't worry about using your calculator. Okay, I'm just doing this for whatever. Anyway, let's see what we got here. We got 4 times 3, which is 12. Okay, that doesn't help me out because I don't know what 12 times 7 is going to be. But what I do know is I know that 21 times 4 is 84. And it's a good thing I mentioned the square root of 400, or 20 times 20, because it looks like we're going to need it again, because 484 minus 84 is going to be 400. And we know it's a square number because I just got done explaining that 20 times 20 is 400. So that means we're going to have 2 real rational roots. There we go, 2 real and rational. And last one here, and again, I'm just going to go through these kind of quick. I know I usually explain things, but I'm also going to show you that it does not take that much time. Now in this case here, I'm going to leave 1 out because it's just a positive 1. Oops, don't forget the sign. Don't forget that negative. That's part of it. So 6 squared is 36. And in this case, it's going to be a plus because negative times negative. That'd be 60, and that would be 96. So the question is 96 a perfect square number? All right, so think about it. So 9 times 9 is 89. 10 times 10 is 100. So 96 is between those two numbers. So it is not a square number. It is not a perfect square number. So it's going to be 2 real and irrational. All right, so it looks like we have 2 of them that are 2 real and irrational. So there's 2 of those, these 2 here. Now here's the next part. So if you have your packet in front of you, it's going to tell you to solve each of these using the methods they have on, I think it's that same page. But what we're going to have to do is we're going to have to pick which one of these is the best method. Now, I already, oh, oops, I think I pushed the wrong button. Oh, yeah, here you are. So picking the best method. Now I already have them in here just because it would take a while, because at first glance, some of these look like they might be able to be used with other types of problems. Now, for this one, equation B, it's missing its B value, which means immediately the first thing I know is that it's going to be best used for the square root method. Because in order to do the square root method, I'm going to minus 144 from both sides, right? Just move it over to this side, minus 144. I'm going to try to get that x by itself, and that means I am going to divide both sides by -2. That's going to leave me with x squared equals 72. 72. And then I got to get rid of this square here and then take the root of both sides. X, and then 72, let's see, 72, I can break that into, I'm trying to find square numbers, and I know if I ask students what's the first thing that comes to your mind, they're going to say 8 and 9. But hold on a minute, 8 and 9, 8 can be broken into another square number. And this also works pretty well if you use the other method that we taught, and that was, what numbers can I multiply to get to here? Which in this case, 2 times 36. So again, pick numbers starting from the lowest and then work your way up to higher numbers, which in this case, we've already reached our largest square number. 36 is a square number. So in this case here, I'm going to have the square root of 2, square root of 36 times square root of 2. Since I can take the square root of 2, I'm sorry, not the square root of 2, square root of 36. There we go. And that was probably the easiest one to do, because again, if we looked at the chart, which I showed just before coming to here, if there is no B term, you can easily use the square root method. But then with these other 3, you'd have to do a little bit more thinking. All right, so which one should we use with the quadratic formula? Which one should we use with factoring, and which one should we use with completing the square? So let's see which ones are the best, which one would be the best candidate for factoring. So for factoring, you want ones where the root is rational. So in this case here, I don't know if I could, no, I can't factor this one, can't factor that one, can't factor A. The only one I can factor is this one because it is the only one with rational roots. So that's why this next one here is going to be the factoring example. So I'm gonna go ahead and put that one here, which is already there. And let's try our best to factor it. Now, again, this is the only one we can factor, but it is still gonna be pretty difficult because we have an A value. Now, there are some other ways to factor this, but I'm gonna go ahead and use the AC method, which we've already covered. You could also use solve by trial, which means you just keep trying things until something works. But that's kind of hard when you have a fraction, which in this case, just by looking at the discriminant, we know we are going to have a fraction. So I'm going to go ahead and move the 3 over here. Now we're going to give the 3 here, right? When you give something, you're going to have to take it back. And in this case, we're going to have to take it back later. All right, so what we want to do is we want to use our Loif method, as I call it. So look at the last number in your standard form quadratic. In this case, it's 21. I need 2 numbers that will multiply to 21. Now, before you start picking numbers, I like to work with the signs. So look at your sign as well. In this case, it's a plus, and the plus means they will be the same. If they are the same, they will be the same as whatever the first one is. And that makes things a lot easier. All right, you can easily pick better choices if you know what sign you're looking for. Otherwise, you'd have to keep guessing and checking, and if it doesn't work, try something else. But this allows us to get fewer guesses. Now, we could get 2 numbers that multiply to 21, which if I ask students what's the numbers that would multiply to 21, they would say 3 and 7, but there's a bit of a problem here. -3 and -7 do multiply to positive 21. But remember, the 2 middle numbers, the 2 numbers, the outside and inside, must add up to the middle number, which in this case, -3 and -7 will not add up to 22. They will add up to -10. So that's not going to work. So 3 and 7, not going to work. Well, in this case, there's only one other option. There's only one other possibility, and that is 1 times 21, which, 1 and the number itself is a possibility because -1 times -21 will just switch the sign to 21. That works. -1 and -21, put them together, you will get -22. So that works out. This means that this is our proper answer. Well, we're not at the answer yet. We have our factors actually. So these are our 2 factors. Now, remember, if we give something, we are going to have to take it back because nothing in math is free. I can't just be giving out numbers, So since I times this by 7 and then we factored it, I am going to have to take back that number again. So I'm going to divide both of my factors by 3. And this gives us, and I'm gonna run over here really quick to do the rest of it. So I have x minus 1/3 equals 0. And then I'm gonna work on this one because remember, these are set to 0. So we have to use the 0 product property, which basically means what do we have to plug in to make them equal to 0? So I'm gonna go ahead and put the other one. So we have x minus 21 equals 0. And then we solve each of these. Now this first one here is, I'm gonna do this one first just because it's the easiest one. Just add 21 to both sides. And x equals, 21 divided by 3. My bad. 21 divided by 3 is 7. So that actually means I need to add 7 to both sides. So x is equal to 7. So I got one solution. Let's get the other one. So in this case here, it's just going to be the opposite of whatever is in there. So in this case, to undo this, I'm just going to add 1/3 to both sides. Now, you might also remember that I told you could just go with the opposite of whatever is in your factor bubble. And that works too. And that works a lot better. So now I can see my 2 solutions. X is equal to 1/3 and x is equal to 7. So now I'm going to go ahead and put that here. So x is equal to the set of 1/3, and 7. So those are our two solutions that we have for this one here. And again, there are other ways to factor this, but I'm going to go with this method, and that works. The AC method works on anything that has a number in front of the x square, which I think actually the thing warned us about it. No, okay. Oh, no x square coefficient. All right, that's not exactly the same thing, because even if you're going to factor it, sometimes it's okay to have an x square coefficient. All right, next one here. So what would be the next one? So if, again, looking at this one here, assuming that okay, because I already put them in there because I didn't want to waste time getting the wrong one and then using a different method, because that will happen. You know, if we had more time, I'd say let's go ahead and just keep trying, and if we make something wrong, let's just go back and work on it. But I know in a situation like this, no one wants to waste time going back, so that's why I already put them in there. So we already covered this one, and we covered this one. So the only not that, was it this one? No, we covered this one and this one. So these are the two of them that we already used. So that leaves us with only A and D. Those are the only two that we have left. All right, so what do we do if there's imaginary roots? Okay, so imaginary and irrational, what do we do with those? So we only have completing the square, so that's the one we have left, and quadratic formula. Those are the only two left. And again, I'm just showing you how you would figure out which one is the best one. So again, quadratic formula can be used on any of them. But it also works best if you have imaginary and irrational. Because imaginary and irrational can really be a bit of a headache, right? Because with imaginary, you're going to have square roots of negative numbers. And with irrational, you might have roots of numbers that cannot be broken down. So that's really when the quadratic formula works. So if it has either of these things, then let's use quadratic formula on it. Which in this case here, this one is imaginary. So this one is probably going to be the best one to be used with quadratic formula, which means this one here is going to be best for completing this square. And I'm going to do this one here. So complete square, which we don't need to put that in there. So I'm going to go ahead and move over to this one here for the quadratic formula. And quadratic formula is, again, it's the big tool. It's the big tractor, works on everything, but it does take a long time to set up and it takes a long time to get it working, but it will solve anything. The only problem with it, though, is you need to remember everything. That's the only downside. But if you have this memorized, or if you have a list, like if you're taking a test and a reference page has this, then it's a good method to use. All right, so let's go with negative b, which is going to be opposite of negative 9, which there's a negative with the formula, but then this 9 also brings one, so I end up with two of them, plus and minus square root of b squared, so that's going to be negative 9 squared minus 4 times a, which I'm going to go ahead and leave that off because I don't really need the 1 in there. In fact, you know what? We already know this. Because I already know what the discriminant is going to be. It's going to be 96. So actually, you know what? Half of this is already done for me. Oh, wait, no, that's not the right one I'm looking at. Let me just go back over here. I'm looking at this one here. I'm sorry. And I mistaken it for that one. But yeah, this is the one we're working on with quadratic formula because this one's completing the square. This one's quadratic. I just pointed out the wrong one, that was all. But anyway, yeah, just going back to that last slide, I can just see it right there. And I'm gonna evaluate this here. So I know it's just gonna be 9 all over 2a. So 2 times 1 is just gonna be 2a. And look at that, plugging it in. We didn't really have to do anything. I mean, like I said, in this case, even more than half of our work is already done for us because we already found the discriminant. Just plug -3 right into that radical Bam, done. All right, so let's go ahead and get that negative out of there, because that's one thing we can't have, okay? Radicals and rationals, or radicals and fractions, are one of those weird things where there's certain rules that we just don't say it like that. All right, we just don't do it like that. It's not wrong, but it's kind of like grammar, okay? You know, I mean, I could ask something like, where did you be at yesterday? And you know what I'm talking about, but that's just not the way people talk, okay? If someone talked to you like that, you'd probably think something was up with them. And that same thing is true with numbers. You know, there's kind of like grammar in numbers too, because we just don't have these. It's not wrong, but you just never do it. So we take the negative out, and that'll give us the imaginary thing. And let's just check it to see if we have anything we can reduce it with. So remember, if you have, like, reduce these three numbers, like take the 2 and see if you can reduce it by any of the bottom numbers, which in this case, there's only one of them. In this case, there is actually nothing. There is nothing else we can do. So this is our solution. And since it has the plus and minus, it already takes account for both of those solutions, just like this one too. All right, so with this one here, you can see both solutions. But if you can't simplify anymore, just leave that in, and that counts as both of your solutions. Because we don't want to write this whole thing 2 more times, one with a plus and one with a minus, when we can't do anything with it. So we're just going to leave it like that. And that leaves us with our completing the square one. And I think this one took the most amount of time. So that's why I left it for the last one. And it's also one of the more complicated processes. That's not to say it's bad, okay? But this one does have a little bit of stuff that you need to know on your own before even working on it. So, oh, and also all 3 of these problems would work best if you could use all of them with quadratic formula, okay? So in a real problem, because this one says you can only use it once. But in reality, if I was dealing with these 3 problems, I would have just used quadratic formula on all 3 of those. Okay, that's what I would have done. That's what, but the directions say we can only use each one once. So that's why I'm just going to use each one time. But really, I would just use quadratic formula on this one also. So let's go ahead and do this. So for completing the square, we need to focus on our b value. We also need to do one more other thing really quick, and that is to open a space and then move 15. So if I add 15 to both sides, plus 15 here, plus 15 there, I move 15 over to the other side. But I'm going to have a space here because I'm going to need to put something in there to make it work. And this is where we need to use a number to get our perfect square trinomial. And with this one, again, that's to take it, half it, square it. So let's go ahead and do the same thing with 6. Oh, actually, you know what? I just noticed that I wrote down the wrong number. That should be positive 6. So take it, half it, square it. All right, good. We end up with a whole number. That's good. So I'm going to add 9 here and add 9 here. So remember, whatever I do to one side, I have to do it to the other. If you give something, you're going to have to take it back. Because again, in math, there's no freebies. Everything has to be balanced. I mean, balanced as all things should be. I really need to make that a poster. Anyway, so what I'm going to do now is I am going to break this into a factor like this. In fact, actually, I usually write, if I'm doing the work, I usually write it in green. I'm showing what I do. I write it in orange, and purple's kind of like rewriting it, and blue is showing a special operation. Anyway, let's see. 2 numbers that multiply to 9 but add to 6. Well, 3 times 3 is 9. And what kind of sign are they? Well, we want positive 6. So negative, negative? Nope. Because negative, negative, if this was a negative 6, that's how we would get it to be negative 6. But since it's positive, that means these are also going to be positive as well. So we end up with something like this, and I'm going to go 15 plus 9, and that's going to be 24. So there you go. That's the next step. Now we need to make this into a perfect square binomial, or, well, we did that ourselves. That's why we did the whole take it, half it, square it thing. Now here, I'm going to combine them so that they are both the same thing because they're both x plus 3. Now to get rid of this square right here, that's the square we want to get rid of. I'm going to take the root of both sides because remember, squares and roots are opposite operations, or I should say inverse operations. And that will get rid of this x plus 3 so that we only have x plus 3 there. But we still have this square root 24. Now don't forget the plus and the minus, because that anytime you take the square, you always have to consider the plus and the minus, right? Because separate example here, but if I ask you what can x be, so that oh, not 3, getting ahead of myself, I already knew what the answer was going to be. If I ask you what number can I square to get 9, first question I'm going to get is, or first response I'm going to get is 3. But negative 3 works out because negative 3 times negative 3 is also positive 9. So we have to consider both the negative and the positive. Now we also have 24 here. So I'm going to need to break down 24 into some factors. 24, and I'm going to go 1 times 24, 2 times 12, 4 times 6. Now here we can stop because I've run into the largest square number, because none of these are square numbers. 24, 12, and 2, those are not square numbers. 4, however, is a square number. So 4 and 6. But we're not quite done yet, because we need to be able to minus 3 from both sides. So x equals negative 3 plus and minus, and then take the square root of 4, we get 2, and 3 stays in there. Oh, sorry, 6 stays in there. What am I talking about? Where did I get 3 from? Because we took 4, right? Take the square root of 4, you get 2, but the 6 stays in there. I probably looked at it from here. I was eyeballing when I looked over there. That's probably where I got the 3 from. Now, sometimes you can leave that negative out, but in this case, I'm going to go ahead and leave that in there. No. It's only when the negative is the bottom one. But again, if you're unsure, just leave it as is. I know that's something that's very common, so I usually don't mark students off if they leave a negative in there. So when in doubt, just leave it in there, okay? And that's it. It looks like we are done with choosing the best method. So that's how you find out which one works out. And again, really, honestly, if this were me and I was given these and I had no restriction to only use one each time, one time, I probably would have just used all 3 of these with quadratic formula. But again, it's also showing that some of these, kind of do have a better fit for all of them. Except for this one, that one was kind of an obvious one. And it was pretty quick and easy. But anyway, that's it for this lesson. But just a reminder, on week 18 packet, that one will count as your final exam. Now with the final exam, I think I can go ahead and go over it really quick because I think I already have it up on the Schoology. So I'm just gonna kind of go over it since I have a few more minutes here. Actually, I don't have a few more minutes. But there is, I know there's going to be some questions. I'm going to go ahead and kind of answer them really quickly. So week 18 packet is your final exam. And it does kind of have a page in there explaining how it works out. But I know I'm still going to get some questions on that. So week 18 is your final exam. And it says due 5/24, but please turn it in sooner. You got your standard grading rubric. Now this is the part that's a little bit different. So there's just this final exam has 3 individual pieces. Chapter 1, Chapter 2, and Chapter 4. And these will count for the attendance on that final week of Tuesday, Wednesday, and Thursday. And then this is why I had to make that amendment packet of like week 18, part 1 or something like that. Because otherwise there'd be a day missing from here because there would be no Monday. So each exam gives you a maximum of 17 points. Now you cannot get more than 17 points on any one of the exams, regardless of how many correct you get. So some of them have like 24, 25, or 26 questions, but it maxes out at 17. Now, you can choose which ones to do, so you don't have to do all of the problems. but you can improve your chances of getting a high score by doing more of them. So it's kind of like extra credit. So after you answer 17 correctly, the rest will count, will not count actually, but if you do miss some of them, like let's say you answer 20 of them, all right, you answered 20 questions, but you got 18 right. That would be 17 out of 17, which is a 100%. But what if you answered only 17, but you got 3 of them wrong? In that case, you'd have a 14 out of 17, which would be an 82%. So in a way, it's best to answer as many as you can. So to improve your chances of maximum score, do as many as you can in case some of the ones you already answered are incorrect. The ones that you do get correct will replace the score of the wrong ones up to 17 points. So you will not get any points for doing the cross out ones that have been crossed out. So there's no need to do them. Now there's also another one. If you answer 17 out of 17 on all 3 of them, you can get a 51 out of 50 or a 102%. All right, so again, it sounds a bit weird, but there you go. So just do as many as you can. And again, your score maxes out at 17. So whatever you get out of 17, that's how much it is. And some of these, like I know they're too difficult, or I didn't spend enough time on them, or like in this case here, this one's just got a lot of fractions in it, so it would have been a lot of work. And this one has 30, it has 31 problems, but some of them are crossed out and you only need to do up to about 17, that's it. So hopefully that kind of gives you an idea on what you would expect on the final exam. And like I said, I thought I'd just go ahead and explain that right now. Well, anyway, that'll be it for now. We only have one more lesson and then we'll be done with this week. But I think there's going to be like 1 or 2 because I think my bosses still want me to do lessons up on the last day of school. So the packet has a few extra things that are included, but will not be on the final exam packet. But it's just basically, I think, to keep us busy or something. I don't know. I was just asked to do it, so whatever. Anyway, that's it for today. I will see you next time. Bye.